factor theorem. So the factor theorem states that if we have P of A equals 0 in a polynomial, then x minus A is a factor. So what does this mean? This means if we take some polynomial P of x divided by x minus A, there'll be no remainder. So let's look at a simple example to get started. Let's say we have some polynomial P of x equals x squared plus 7x plus 12. We're going to find P of negative 3. So we'll have minus 3 squared plus 7 times minus 3 plus 12. So we'll get 9 minus 21 plus 12. That's actually going to give us 0. So we can say, therefore, x minus our a, which is minus 3, which is x plus 3, is a factor of P of x. Which means, if we took our polynomial P of x and divided it by x plus 3, we'd get no remainder. So how can we use the factor theorem to help us out? Let's have a look at this polynomial. P of x equals x cubed minus x squared minus 14x plus 24. So we've got a cubic polynomial here. Now, we can actually use the factor theorem to theoretically factorize this polynomial. And the way we're going to do that, we're just going to sub in numbers into P of x, which hopefully are going to give us 0 and tell us some of the factors. Now, how do we know what numbers to sub in? Well, that's all going to depend on our constant term. So our constant term is 24. So we need to actually look for factors of 24 to sub in. So we're going to look at plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and plus or minus 24. And the reason we consider both positive and negative numbers is because we have a cubic polynomial here, which means potentially there's 3 solutions for x and potentially like 3 factors here. So we're multiplying 3 things together to get a positive 24. So it is possible we could have 2 negatives and a positive, because negative times a negative is a positive, and the positive times the last positive will give us a positive. So we have to consider both positive and negative cases for all our factors of the constant term. So we can go ahead now and try some of these out. So the first one we'll try out is 1. So P of 1 will be 1 cubed minus 1 squared minus 14 times 1 plus 24. Evaluating this one gives us 10, which is not equal to 0, which actually means therefore x minus 1 is not a factor. So let's try P of negative 1. We'll have minus 1 cubed minus 1 squared minus 14 times minus 1 plus 24. So if we evaluate that, we're going to get 36, which again is not equal to 0. So therefore x plus 1 is not a factor, because we get x minus 1, which would give us x plus 1. Let's try P of 2. So we get 2 cubed minus 2 squared minus 14 times 2 plus 24. Evaluating this one does give us 0, which actually means therefore x minus 2 is a factor. And the goal here is to factorize this polynomial. And we know that x minus 2 is one of the factors. So another way we can think about this so far is that we know this P of x, our polynomial, can be written as x minus 2, and potentially 2 more factors if there are 2 more factors. We just don't know what they are. So once we have one factor, we have a couple of options here. We could keep trying solutions, keep trying some of these numbers and keep going until we get two more, where they both equal 0, and then we'll have our two factors. Or we can divide the polynomial by a factor we've gotten already to we'll end up with a quadratic because we have a cubic and we have a linear function, and we take this and divide it, we'll be left with a quadratic, and we might be able to factorize that quadratic ourselves. So we could go ahead and do some long division. I'm not going to run through it, but you'd end up just taking your p of x, which is x cubed minus x squared minus 14x plus 24, dividing it by x minus 2 with the long division method. You would get a remainder of 0, and you'll get x squared plus x minus 12 as our answer, which means that now p of x, our function here, can be written as this multiplied by this, because there's no remainder. So therefore p of x is going to equal x squared plus x minus 12 multiplied by x minus 2, and that quadratic there we can easily factorize just by picking out two numbers that multiply to negative 12 and add up to 1, and that's going to be plus 4 and minus 3. And you can see p of x is now fully factorized using the factor theorem.
I really hope you learned something new today, and if you did, subscribe to us on YouTube at LaHood Mathematics, follow us on Facebook and Instagram, and visit www.lahoodmathematicsplus.com.au to multiply your success.